All right, hello everyone. What is happening today? Today we're going to do a little bit of physics hacking. Expose some functionality to Zig that we haven't had before. First of all, let's make sure that I can actually build and run this thing. I have been working on audio lately, as some of you might know. And as part of that audio work, I need to actually make the vehicles in the game make all kinds of impact, have all kinds of impact sounds and the like. Let's actually shut off the background music for a bit. So, hopefully you can hear some audio from the game. There's a little bit of ambient noise. If I pause the game, you can hear it go away. It's a little abrupt, maybe. Might have to do some kind of fade in and fade out on that. But we do have a bit more audio now. We even have some of these almost like horror-like stingers playing randomly. And this game is of course not supposed to be a horror game in any sense of in any sense. But I've been messing around with some sound effects to see what sort of fits. Some of these almost came out a little horror-like, so we'll see what actually ends up sticking. Anyway, the car has some new sounds. We have the engine sound that we've heard before, but we also have some like skidding and things like that, which you can hear if I start skidding around. They're not actually very loud. You can turn off all the other sound except those. You can hear them a little better. Things like this. It's basically just like a modulated noise almost. And yeah, we have some like tire noise, which is played as long as the car has at least one wheel actually touching the ground. So if we get some air time, you can hear it go away. It's kind of faint. It sort of sits in the back of the mix. But I'm starting to like it quite a lot. Especially the skidding. I think starting to kind of work quite well. But we still don't have impact sounds, and that's sort of the big problem here. If we land on the ground, if we get some proper airtime here, and then we land, you would sort of expect to have the car like this. You'd expect to have the car make some sort of bump sound. And of course, if we're driving into this cliff here, you also kind of expect it to have some sort of bump sound. All of that's still missing, so we need to do something about that. Let's re-enable the rest of the soundscape. And so that would be my my next thing to look at for this whole sound plan. I mentioned in a previous stream that I sort of promised myself that I wouldn't be working on anything but audio for a while, and that's still true. However, this physics work that we're gonna look at today is gonna be very much sort of in service of the audio. So that should all be good. Yeah, the background noise might be a little too loud. But I guess I need to do some sort of mastering pass or something, if you can call it that, later on. Yeah, again there you would have expected to hear some sort of crash sound when we drove into that rock there, right? Yeah, there's some booms and things like that you can hear in the background, but they're just part of the background sound event, which is sort of semi-randomly playing some audio stingers to sort of reinforce this idea of this being sort of an industrial place. So those booms aren't actually related to the car at all. Yeah. All right. So, I was thinking, let's turn on the background music again. It's a little loud, maybe. Something that I've used in the past, not actually to play sounds, but particle effects. Is the physics system, the collision detection. Let's try to load the data for Project Slide, which is like the same game engine, and sort of like an earlier incarnation of this game. I'm just waiting for this number to go down here. Hey Matt, what's going on? All right, so that built. So we should be able to run this. Let's see if we can actually do that. So I'm just gonna load straight into the demo level without any kind of mission or enemies or anything. Let's spawn another car for us here. Car 2. Oh, rain for you as well. Yeah, it's been very rainy here today. Let's see, let's set up FPS cap to 60. Not FSP cap, but FPS cap. Thank you very much. Let's try to run this at a reasonable frame rate. Yeah, you can hear some. This is a slightly different audio feel to it. It also has some kind of grunge going on with this. This is basically like the same sound effect as it is in Traction Point now. But anyway, so this game has some dynamic objects actually spawning particle systems. Like if we like push these guys around, you can occasionally see them actually giving off particles. Let's see if I remember how to actually play this game. Here we go. It was maybe a little tricky to see. See if can I lower the volume for this a little bit. Audio master volume 0.25 or something like that. Alright, so if you're actually shooting these things and making them fly away, you have like these puffs of smoke here. Those guys are actually sort of spawned through the physics. You can see when this lands, it will probably spawn one as well. Yep. So here's a puff of smoke, and some more when it landed there. I'm using the same physics layer for this as in Traction Point, the new game that I'm working on. We can also get puffs to appear by just shooting the ground. Well, that's not actually the same system, that's just a raycast. Anyway, so basically what we want to do here is whenever there is a collision between something and something else, we want the physics engine to tell us so that the gameplay code can actually play a sound and potentially also a particle system in the future. But currently we don't have that in Zig. We don't only have it in C++. And that also includes things like, you know, the vehicle just driving into things. There are no collision sounds in this game either. I never got that far before I abandoned this. So you can just drive into the cliff and nothing really happens. But the idea would be the same, and this time I'm gonna do it. I'm gonna leave it like this. So we need a way to actually get collision signals out of the physics engine and somehow into the gameplay code, so that we can trigger those sounds to begin with. And then later down the line, I'm gonna do the particle systems. There's some pretty cartoony particle smoke. This one uses a slightly more I don't want to say photorealistic particle effect, but I guess in fact it is probably more photorealistic than what we have in Traction Point. This game uses a slightly more realistic art style, more detailed. And yeah, this level is still fun to drive around in, for sure. So let's have a look at how it does that. There's something called, is it contact? No, it's collision effect manager. There we go. So this thing has an on collision function or method. Importantly, it derives from scene collision listener. So Basis Physics API scene collision listener, which has one virtual method on collision. So this is what we actually want to hook into. And then in that, we get a collision data, so a data about a collision, and the collision data has some things in it. So it has two shapes. It has a number of collision points, maximum of 8, and then just a count. And collision point has position, normal, impulse, force. Importantly for us in this case, since we want to play sounds, we need the position and we probably need the force as well. In the future, I might need the material so that I can figure out what I actually want to play. What kind of sound effect? If it's like a wood against wood or rock against metal or whatever. 1 second, phone call. All right. So, the problem here, of course, is that we can't derive from anything in Zig. We can't derive from a scene collision listener because there's no inheritance in Zig. So we need to somehow have this on collision called for us in a different way. And yeah, just to sort of continue my my train of thought here, if we look at what this actually does, it figures out if the force is small enough that we don't actually want to play anything, we just continue. And we get the dominant material out of this. So I guess like a dominant material is sort of like, let's see, if we have gravel and gravel, then it's gravel. If we have grass and grass, then it's grass. Well, that's interesting. But yeah, if we have... What? Oh, that's an ore. Yeah. Yes, I know programming. That's an ore. So if we have gravel or gravel, then it's gravel. Yeah. Alright, so this dominant material doesn't really do like a whole lot of actual logic currently. I guess I did it like this because I was thinking about filling it in at some point. But anyway, we play a sound effect and we play a particle effect. And so from the material we get a material FX entry. And this probably has like some particle effects. So there's like bullet hits, some slip particles for the tires, and then some sound effects. So we can play them like this. Not necessarily going to do exactly the same thing this time around. I'm thinking if we just get this on collision call, we can then figure out what we actually want to do with it, right? So the thing is though, we can't do this. We can't just get the primary physics scene in Zig and then add the collision listener to it, like this. That won't work. Because again, we don't have inheritance, we can't just like inherit and call some virtual functions in Zig. And so the way I've done it with triggers, which sort of does like a slightly similar thing. Physics trigger.zig. Actually, we can look at the C++ version first. So trigger has set enter callback and set exit callback. Enter callback and exit callback. Like quite simply, they get called, and then that's a delegate which triggers something. The way I do it in Zig is not using a method, but rather using a global function. It's not really a global function, it's just a normal function. Living in basic physics trigger register enter callback. Then you give it the trigger that you want to trigger on, and then you get it some sort of delegate. In this case, we actually call it on a method object entered here in the whatever this is. Dynamic object receptacle component. So the idea here is that whenever something enters this trigger, I want to call this this method. So I'm thinking, well, we might want to do something kind of similar to for the collisions. We have a global function, or again just a function. I don't know why I call it a global function. Just a free function. Free. It's not a method. It doesn't belong to any struct or anything. A method that we call. We give it the physics scene, and then we give it some delegate to actually call. Yeah, there's a void delegate 1, so it takes one parameter of some type. And I'm thinking like to here, we can probably see it here. So void delegate 1, physics actor pointer. The exit 1 is a void delegate 2. I think that boolean there is whether or not that object was actually deleted. So that's why it has exited the trigger, because it was actually completely deleted from the scene. So something like that. And when we get callbacks from collisions, then we can do something. Start by doing something fun, like just visualize all the collisions in the scene or something like that for some number of frames. And then we can start messing around in the scene, and we should see some stuff appearing where we have actually touched things. So let's do that. Let's start by going to physics scene, I think. So you can see here the register and unregister. These actually sit behind a mutex. So typically you would register these things at startup, or whenever you create an object that actually like wants to listen to these trigger events. But the callbacks then go into a map, which you can see here, auto hash map, and this guy actually needs to be protected. So it's protected by a mutex here. This is also or almost kind of like global data. That's why I use this underscore, or not underscore, but like smaller case g here before. So that's initialized to false. We actually need to initialize it because this map here needs an allocator. So this is called at startup time at some point. Let's actually figure out where that is. Yeah. So this is the app, the application type for this whole game. When it starts up, it initializes the physics triggers, and then it de-initializes them when it goes away. So that's fine. We can do the same thing for the collision listener. That should be a-okay. So how do we actually want to split this up into pieces now then? We could throw the whole thing here. So there's the physics scene. The physics scene is in some sense the thing that will host these callbacks. The callbacks are coming from a physics scene. But if you look at this type here, this struct, it basically just forwards all of the things through the binding system to C++. If you add an actor to this scene here, it just goes and calls it on the bindings. So FP is short for function pointer. And that is why I typically use this like PTR at the end of these types, because they're typically used as, we can think of them as pointers. They actually have quite literally like a C++ pointer here in a usize member. But yeah, we can still sort of think about the collisions as a as being hosted by this scene, though. Let's see, we have a raycast callback system as well. How does this work? So you cast a ray, then you get a callback, and that callback is stored somewhere. Right, okay, you just give it an object. Yeah, that's actually kind of interesting. Nah, I'm not gonna change. I'm gonna change course now. I'm gonna do what I set out to do. Okay, so for the physics scene, we need basically the same things we have in the triggers. So we need like a mutex, a map, and a bool. I don't technically need the bool, but I keep it there for bookkeeping. To actually host these listeners, these things that are interested in listening for collisions happening in the scene, right? So we need these guys on the scene level as well. So let's do that. I have some internal stuff there. Maybe we can keep these things above that. There's public stuff here. Public. And doesn't really matter. Let's just make a new section here and call this collision. Collision callbacks. Right? That's what I call it here on the C++ side, isn't it? Scene on collision, yeah. Right. So we can take the triggers and drag them off to the side. Like that. I'm just going to activate Zen mode here so we get a bit more real estate. So basically, this has a struct for holding an enter and an exit callback. We don't need that. We just need one of them. We still need to actually define this type somewhere, and it's defined up here. Okay. If you go look at this C++1, it's a method that takes one single reference. So it's a collision data. So let's maybe start by actually declaring that collision data somewhere. Physics, is it types? Doesn't really seem to be. I know I have a file somewhere with a whole bunch of physics related things. I might be thinking of vehicles actually, because this actually contains a bunch of physics related things. Okay, so we don't actually have that, but that's not a problem. We will quite simply put them in the scene. So let's do a pub const collision data. That's a struct. And this guy will then have a bunch of things as part of it. We won't actually care about that right now. But what we will care about is actually declaring this here in the physics section. So we have just C, that would be physics scene dot collision data. I'll just copy paste this over. So now the full sort of path or name of this type would be basis.physics.collision data, because this is the physics module, like so. And now that we have this, we can set up the delegate here. So if you want to listen to collisions for a class, you would give it a callback collision callback, which is of type basis delegate void delegate 1, where the 1 parameter is a collision data. So that sort of matches this guy here, this on collision virtual function. All right, that's nice. Maybe we can even keep it right there next to that other one. That's actually kind of more neat in a way. So we have the type here, and then we have the callback type right under it. Okay. So then we need basically these 3 guys. Actually, we kind of need those 4 guys. So collision callback map. I'm not going to call it state map this time around. Just collision callback map. And it's an auto hash map. Int pointer. This is really just an alias for a usize, as you can see here. And that's just a callback, right? It's a map from an int pointer to a callback. Is that right? Right. Yeah. I realize now that the trigger system is set up so that you can only have one callback for one callback per trigger, like one enter and one exit callback per trigger. That might be all right for this as well, because from that callback you can then, like, you know, spread it out into however many places you want. So that's actually completely fine. It might be a little overkill though to have an auto hash map for that, right? That's a little crazy, maybe. So instead what I'm going to do here is I'm going to have an internal type that I again call collision callback state. And it's not a public struct, as you can see, because no one is actually expected to poke at this guy. And this thing will have a scene int pointer, type basis int pointer, and it will have a collision data. No, collision callback, so CB callback, like that. It will have those two things. And then we will quite simply have, let's see, do we want to have like a vector or an array list, I guess is what it's called in Zig. So we would have collision callback list, an array list of these guys. Collision callback state. These trigger names need to be collision instead, like that. And that's just a list of them. Yeah, there's a little bit of boilerplate here in the beginning. It's not necessarily super interesting, but actually not that much. So I'm thinking this is probably fine, because we'll have, like, typically we have 2 scenes. We can have you know, 1,000 triggers. And that's why this is actually a hash map on the trigger side, but we typically only have 2 scenes. We have one on the client and one on the server. You can create more if you really want to have more scenes, but that's typically how it goes. And so, because we have only 2 scenes, we can just as well have this as an array, like a dynamic array sort of thing. Yeah. That's probably fine. We might even be able to have it as just a static array, but I'm gonna keep it as an array list for now. It's fine. It's all good. So then we want to have some sort of way to actually initialize these guys, right? So this just sets the boolean. We have the state list here that we need to fix up. Now we can call this guy here from the means app, the same place we initialize the triggers. So go to scene, init, and self.allocator. And then we do the same thing here. Let's do the reverse order just to be sure. Like that. And there's just one thread running at that point, so we don't need to worry about the mutex yet. Right, so then we'll have the register callback function. So register collision callback. And we'll do it for a scene. So physics scene pointer. And the callback is one of these callback types. So collision callback. Right? That's it, and then we'll also want to have an unregistered collision callback, and we can just, since we only have one per scene, we don't need to actually give the callback, we just give the scene. Hey, register the callback for this scene. That should be fine. I'm gonna move my microphone just ever so slightly away from me, so let me know if the audio is suddenly too low. I'll up the volume a little bit, but it should be fine. Let me know in the chat if you can't hear me properly. Okay, so that's basically like the API for this. You register a callback when you have one, and you unregister it later, some later point. That's basically it. And then the system automatically calls that thing from one programming language to another. And that's now where the complex stuff is going to come into place. But one thing at a time. Let's register this thing first of all. So we're going to want to use this mutex here to protect this part of the code and the other one there. Technically, I'm not exactly sure if this is needed, because the scenes are created in a place where I guess there might be 2 threads running. The server typically runs on another thread than the client. The server is the one that typically has the other scene. So depending on how the loading goes, I guess they might both try to register at the same time. So I'm gonna keep it there. I think that's probably the only place where this thing is used. Okay. Yeah, it's used also during the actual collision, or in this case, the trigger event. Yeah. I think we might want to actually change this a little bit, so it's just going to get the callback out of the list, and that part is handled by protected by the mutex, and then we'll actually we will do the handling of whatever you want to do when a collision happens without the mutex. There's going to be a slight optimization here, because there's really no way for a thread to be reacting to collisions at the same time it is actually removing like a lock. Or maybe there is technically, but like in theory there might be, but that's really not something that you want to do. So let's not concern ourselves with that. But yeah, we will want to have, just like we have here, on trigger event, on trigger enter event and on trigger exit event. We will want to have here, and I typically preface these functions that I don't want to like accidentally call, because they're sort of meant to be called only by the system with an underscore. So on collision call back or something like that, right? And then we have scene int pointer. I've used usize here, but this is really the same as an int pointer, so it's fine. And then we'll want to have something else here as well, like the interrupt version of this collision data thing. But for now, let's just keep it like this. To do add collision data interrupt, or interrupt collision data, I guess. We're sending some stuff from C++ to Zig, and then we can poke at it in Zig. Okay, that's good. So let's implement this registering. How does that work? I guess we might want to have this thing here as well. Let's make sure that this is actually initialized. So physics scene. And then basically we want to create one of these states and want to push them into the list like this. Scene int pointer would be scene scene.cpp pointer, and that's just CB. So it's int pointer because it is a pointer represented by an integer. My pointers are integers technically, and sort of like a typeless pointer. It has just the raw value. So that's why it's called int pointer. It's called CPP pointer because it is the pointer to the thing that lives in C++, like a C++ object. Like so, and then we need to try g collision callback states append, right? State. Like that. That should be good. I guess we can just technically take this guy and just put it there, and we can get rid of that. That's the registering. Then we have the unregistering. And we can definitely protect this whole thing with the mutex. These things are going to be run at like startup and shutdown basically. So no problem there. So I do think we need to basically iterate over the things in the collection. And of course there will be essentially just, you know, two things. Items. So we'll have state here. And maybe we'll actually do do this so we get the integer as well. Like that. And if the state scene int pointer equals whatever we gave it, remove, probably ordered remove, I guess, like that, and then we return. Yeah, if there's a more elegant way of removing based on some data in an array list, let me know. That might be some nicer way of doing that. But that's basically what we need to do. Let's make sure this actually builds now by building it here, compiling it. And it does. That's good. Thank you. So now we have basically the whole API from the point of view of the user working. We can set up a collision, and we can register and unregister. Of course, this collision data is completely empty still, so there's really not a whole lot that we get. We just get the information that okay, collision did happen. Not really any info about what it actually meant. So maybe we should do that next. Maybe we should fill in those classes here that we need. So collision data has two shapes and a number of collision points, up to 8 of them. This looks like a very good place to use the stud bounded array in Zig. Let's copy this stuff and put it here. Comment it out. So collision data. This has shape 0. This would be a basis physics shape pointer. You can initialize it as a. Actually, do I have those just forward declared here? Actor pointer, actor type. I'm just gonna shorten these a bit. So physics shape pointer, const, something like material or whatever. What is it? Physics material pointer. So now we can just use those instead. Let's see, where did I put the thing? Right, it's over there. Now we can just use physics shape pointer. And shape 1, also physics shape pointer. Right, and now we need the collision point. So let's do pop const collision point. Struct. And this wants a bunch of things. So it has the position, which would be a vector 3. I had shortened that. Yeah, vector 3s are shortened. Position vector 3, normal vector 3, impulse vector 3, force, float. Force is a float. Material 0 would be a material physics material pointer, and a material 1, same thing. Like this, and we can just initialize these to make sure that we don't have any problem actually just initializing these guys cold. Material pointer null. Oh, we don't have a null constant here. Why don't we have a null constant like that? These guys probably have a null constant. So shape pointer null. Like this. But the physics material doesn't, so let's just add it there. So it's not anything complicated. It already has an init null, which is a function. Which creates a new physics material pointer with a CPP pointer set to 0, we just call that and assign it to a constant. Maybe a little nicer to use that way. There we go. Like that. Yep. I'm a little annoyed that these guys are here. This is like an implementation detail, and that's kind of also an implementation detail. Might want to think about moving those somewhere else, because like these things that are in between these two separators here, this is like implementation stuff. These guys are actually part of the API, if you will. Interrupt types. Yeah. Yeah, we're gonna have to add these to the interrupt types as like extern structs, so we can pass them between C and Zig at some point. Maybe I'll do it right now. So typically I'll have like a class. If there's a wheel description, there's an interrupt wheel description as well, which is an extern struct. So let's do pub const interrupt collision point, like this. That would be a to-do for now. And same thing with collision date. Like that. Yeah, that looks good. That looks good. So now we actually have the whole API set up here. All the rest is just implementation. Okay. What is the next thing to do now then? I guess we can do this on collision callback thing. So this guy would get an interrupt type probably, right? Where's this called from? Engine API, yeah. Right. So you can see these functions here are exported, export FN. So these are actually exported from the DLL, which this Zig code is built as. Actually, we already have a physics section here, so that's nice. In here, we can't use our normal Zig structs. We need to use the extern structs, so those interrupt types, and then we need to convert them into actual Zig types. So there's a little bit of overhead there. Can't be helped. It can maybe be minimized and helped that way. These are all the exported functions that this engine exposes. The whole sort of flow from the C++ side to the Zig side for the engine goes through all of these. There's a lot of repetition, as you can see, so it's actually kind of small. This whole API. Okay. So we're going to want to create a function here. Call it probably physics on collision callback. And here we want to do scene int pointer basis int pointer. So the trigger has just other actor int pointer here. We don't really have that. We probably have actually the interrupt type. Yeah, like a pointer to an interrupt. Yeah, that is what we will actually have, a const pointer to be specific. So this would have a collision data. Collision data should be a const pointer to one of those interrupt what do we call it? Basis physics. Or is it basis bindings? Interop. Let's see. Interop collision data. One of those guys. I don't know why it didn't show it to me. Right, and then here we can decide where do we actually want to turn this. Oh, 1 second. Interop collision data. That's what it should be called, but it's clearly not called that. Ah, it's because of this. Physics, interop types. Here we have collision data. So that thing right there. Yeah, now it colors it correctly as well. So we can maybe think about if we want to actually convert this thing here into an actual type. So an actual one of these guys. Or not. I think there's only this one particular place where it will actually be used. So maybe we can just do it by hand. But we'll see. I'm gonna call this interop collision data like this. And then we will quite simply do probably a var collision data. And this would be basis physics collision data like this. Collision data, I probably need to do something with something like that to make it, you know, just to allow a var for now. Like if I have a var here, I need to modify it somehow, so just like do that, so make it shut up about the error. And then we will call basis physics scene on collision callback. And we'll call it with the scene int pointer, and let's add one of these guys as a collision data here as well. Kind of like that, probably. Like so. And then here's where we will actually we can do this thing here, and that comment is no longer valid actually. All right, that thing, and then to do convert interop to actual type. Right, something like that. And then here we can basically copy this thing. We will iterate over it, and it will typically only do like one or two iterations before it finds the correct one. So here it will go and do that's the int pointer you want to compare against, and then we do state cb call, and we pass it the collision date like so. Is that good? I'm kind of tempted as like an old C programmer. I'm kind of tempted to make this like a const parameter. I know Zig is sort of supposed to do that for me, but I'm not sure if that actually how well that actually works. So maybe we'll do that for now, and then that needs to be then like an address of. Tapendra asks, how did you learn to make a game engine when starting out? Basically just by building lots and lots of engines and games. And I should probably add, also by actually making games with my engines. I think this is probably like the 4th or 5th or, I don't know, 6th engine that I've built over the years. This one is particularly sort of, how should I say it? It tends to not want to die. It just keeps chugging along, even though it's not perhaps the best piece of software engineering out there. It kind of just works. But yeah, there's not really any other silver bullet for learning how to make a game engine. Just build lots of games, lots of small things. Each game you build typically requires you to learn some new thing. When you've built roughly the same thing 2 or 3 times, you kind of know how to build it. And then you take the code that comes out of that, put it in a library that you can then use for your next game. That sort of thing. And I should probably add that this engine is actually over 10 years old at this point. So it is getting to a point where it's kind of feature complete, one could say. Even though these things never tend to actually become finished, they tend to reach a point where they can do a whole bunch of things. You don't need to, you can kind of work with them without having to like work on them all the time. And it's taken this engine like about 10 years to get to that point. So that's another thing. Just be very tenacious and just don't give up, essentially. Well, yeah, it's a very broad thing. If you're wondering about some very particular part of how did you learn to make this or that, I might be able to give you a more concise answer. But like game dev in general, it's such a broad topic that I don't really know. Yes, 10 years. Over 10 years. There's code in this engine that's really old. I think the state machine is probably like some of the very oldest code there is. Where's the thing? State machine. Here we go. I mean, I'm sure this class has seen lots of additions over the years, but I think this is among the oldest code in this whole engine. And I can't show you like Git history from all that time because I started on like CVS and then migrated to SVN, and then at some point I migrated to Git. So the Git history for this is probably, I don't know. I don't even know. 5 years or something. But yeah, it's really old code. And it's not like, it is used, but it's not code that I like very much or have to touch all that often. It kind of just sits there and works and does its thing. And then there are things like the whole node-based editors and all the runtimes that come with that are much newer, much nicer to work with. And I've been working a lot on that side of the whole tech stack for the past 2 years or 3 years or something. Just keep ramming that wall. Yeah, pretty much. Pretty much, pretty much. Yeah, I mean, I built some fairly significant things that I've never shipped. Like, for example, this game, this Project Slide, this thing. This has never shipped. This is kind of what I was... Oh, very, very loud. This is kind of what I was thinking this game would be about 4 years ago, or 5 years ago, or something. And it took me ages to make this one level, and I realized that I'm gonna die before I get this game out at this rate. And this has some combat in it. The combat is perhaps the biggest issue this game has, because it just the AI for building good combat, the combat AI, especially with vehicular combat AI, that's a whole lot of work goes into making that nice and fun. I don't remember what those outputs are there. There's something. Yeah. Yeah, basically what Matt said, and like I said some time ago. The AI was one thing. That's one reason this game got sort of put on hold. I'd still like to build this game. And spoiler alert, this game actually takes place in the same completely made up universe as Traction Point, on the same planet even. And yeah, there's some derelict spaceships in the sky that might actually make an appearance. Wink, 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 wink. Yeah, so the AI was one thing why I kind of dropped this project, at least for the time being. Let's see if we can railgun that guy out of existence. Boom. That was one thing. Another thing is this art style is kind of labor intensive to actually make working and create all of this stuff. I'm kind of stubborn in the sense that I want to basically make all my assets. I've used a little bit of help, of course. I have some textures that I've bought from some asset pack or something somewhere. Yeah, I kind of just know by heart these places where I can just go without those guys really bugging me. So that's sort of how I know. And that guy had just gotten himself stuck in that ditch there. Boom. Anyway, my point is that yes, I made things like this that I'm just like, nah, this is not good enough. Just let's start over. And when you do that enough, you kind of get at least some amount of good at doing these things. You can see that the combat is not very engaging here. These guys are sort of just roaming around the place. And when they see you, they will shoot you. And quite often they actually just basically drive into you. And you can see that we actually have a lot of health points just because you can actually get killed relatively easily in this. Oh, got stuck on the unfinished house ruin there. Yeah, I left this and started on Traction Point, exactly. It is the same engine, So a lot of the work that I did for this is directly or indirectly usable interaction point. Now this guy is going to try to make their way to the garage. We need to meet him there. Yeah, so a lot of the work that went into this are just things that I would have had to do for traction point as well, so it benefits from that. And I also just learned a lot about making assets and things like that while doing this, so it wasn't wasted work, but there was still a significant amount of wasted work. I haven't played this in a while. I don't know if this mission is gonna work. So basically, we need to switch vehicles to this thing, and I'm going to haul like a trailer out of here. This hauling is something that I've been meaning to put into traction point as well. I could basically just port it if I ported it from C++ to Zig. It should basically work. I don't have anything in the trailer, but I can spawn some barrels here if we want to. Hey, now we have cargo. And now Diego, our friend there in the other car, is going to escort us out of here. And he's really bad at driving. So driving is one thing that the AI in traction point is just way better than this. I used a third-party, what's it called, behavior tree library for building this AI, and I don't really like behavior trees. I'm sort of like trying to prove to myself at that point that like I'm just bad. I'm just gonna have to learn to use behavior trees to build things, and they have to be good because everyone's using them. And I didn't get very far. Traction point doesn't use behavior trees. It uses state machines and some fuzzy logic. Oh no, there's a combat badger coming this way, and Diego's stuck on a tree somewhere. Oh shit! That thing is gonna basically blow me to bits unless he comes and kills it for me. You can see the AI routes that they're going. Oh, I got stuck on another thing. You're so bad. Stupid idiot. Oh, they're gonna fight it out now. Kill him, come on. Oh shit. Oh no. Oh. Alright, so he did kill it. But I got killed. Need to turn on the UI here. False. There we go. Ah, such a bloodbath. Oh no. Okay, apparently it like reloads the thing. How do you like working with Zig compared to C++? I like it a lot. Yeah. I might like working in C++. I have days when I work... Oh, what? Alright, the okay. Yeah, you can see this target here is where we were actually supposed to go after we killed that guy, but apparently the mission didn't reset. If we drive a bit forward, it will probably reset. I will jump to Diego, who's hanging around in that scout over there. There we go. Yeah, I might have a day or two when I like working with C++. And it's never because of C++. It's never thanks to C++. I never feel like, oh, this was such a nice thing to work on because C++ is such a nice language to work on. No, it's always because I'm working on something cool. Like a lot of the tech stuff that's powering Traction Point is still C++. Like for example the node graph system is written in C++, and it's really nice and fun and powerful and everything, and it might be fun to work with that even though it's C++, but that's because the stuff is actually cool. I still kind of hate having to use C++ to build to work on it, and I've considered rewriting it in Zig. The problem is then that it wouldn't be a problem rewriting it in Zig. The problem is that it touches so many things, so many systems that are also in C++, that it sort of makes sense to have it, keep it in C++ for this game. So that's sort of my opinion. I might like working on something even though it's C++, but it's not because C++ is a nice language. With Zig, on the other hand, I still probably like working on things that are cool, but I might just occasionally go like, oh, this is so nice to do in Zig, because Zig is in many ways more sort of either more explicit in a good way or just more concise or more safe, more modern. Just the fact that you don't have to really think about like linker errors, for example. You don't have to think about where you put something, because if you rebuild a piece of code, it's gonna cause like an hour, not an hour, but 10 minutes. It's gonna cause it to rebuild for 10 minutes because you changed something that was in a header, things like that. It's just things that are just super nasty to have to think about. That doesn't mean I like everything about Zig. There are things in Zig that I would like changed or added. But you don't have to like everything about a programming language to like working with it a lot. And I like working with Zig a lot, so. I feel like state machines are sometimes just a much nicer approach, and behavior trees can get a bit overly complicated. Yeah, it's not really that behavior trees are necessarily all that complicated. It's just that sometimes what you need is a state machine. Sometimes what you need just isn't really possible to model with a behavior tree, if that makes sense. Like if you have an AI, and an AI can have like a patrolling state, like these guys over here. Have a patrolling state like this. They just drive around, and then when they see you, they go into another state, which is like the happy state or the angry state, depending on whether or not you're an enemy or not. Then that is a state machine, right? It's not a behavior tree. Behavior trees are nice to model things like do this and then do that and then do that and then do that sort of thing, like sort of like a recipe. So like do this, and if this happens then do this, and if this happens then do this. State machines or behavior trees can be kind of nice to model that sort of thing. But to set up just like a network of states and the rules on how to move from one to the other, that's really not something that behavior trees are very good at doing. And so some sort of hybrid model could be kind of nice, I guess. But I don't necessarily even need that. I think like state machines, like a healthy mix of state machines, scripting, perhaps some fuzzy logic. That gets you very far. At least it has so far in my projects. Does Zig have a good package manager? It has a package manager. I don't know if it's good or not because I've never used it. I don't really use packages because my platform is kind of basis. If you get what I mean. I basically only use two pieces of. Let's toggle off the Zen mode here. I basically only use two pieces, or maybe is it three pieces maybe of third-party code. So in basis, it's like the engine level. We have a string library. So Zig string, or it's based on it. I've added some stuff here, and this is just like one file. And then the game traction point, which is called means in all of the code and all of the data. This has, yeah, it has another. It has the Zig FSM. So actually like state machines. Both of them are just one single file, so I don't really need a package manager per se. But yes, Zig has a package manager these days. I don't know how good it is. I'm assuming it's good enough. I mean, not even Zig isn't finished itself, right? It's still an unstable language. And if you can deal with some funkiness and junkiness every now and then, it's typically good enough. And I assume the same thing goes with the package manager. If you can deal with a little bit of junk, then it's probably good enough. I will say though that it's using someone else's code in Zig is much nicer typically than in something like C++, right? I have a huge CMake horrible thing for building bases and the C++ games with all sorts of scripts that can well, CMake scripts can barely even be called scripts, but I guess they technically are scripts, so we should call them that. It's like a huge nest of foot guns. While building Zig code is typically just like dropping some files in your project and you're off. I've seen some people use a state machine to control what behavior tree is used for the AI. Yeah, exactly. Yeah, that's kind of what I was talking about when I mentioned the hybrid system. So you have sort of like the decision making would be a state machine, or even just scripting, right? A lot of the stuff that's sort of automatically selected by an AI as part of a state machine can also just be explicitly set by a programmer or designer through a script. But decision making is really good to have in a state machine, and then the actual carrying out of something. Once you've decided that you're gonna drive here and pick up this box, then like that thing is really nice to model, at least in theory, with the behavior tree. Unreal Engine has a new system they made called state trees. Okay. Cool. Yeah. Maybe that is, maybe they do something similar to that. let's just for shits and giggles see if we can actually load any of these other levels that I had. Hey, I'm going on a road trip now. Yeah, so this is just like completely sort of forgotten about almost levels that I've made. I was trying out some terrain tool thingy, I think, for this. That's why you can see that this terrain is actually sort of detailed and like has all these kind of eroded paths and everything. And then I've slapped some rocks on the side of it. Here's one of the first vehicles that I've added, actually. Yeah, I sort of went off on a tangent here, but I don't mind. It's getting kind of late here anyway. I will need to get that physics system hacked though. We'll need to get the physics hacking going. Oh no! Oh no! Now that's supposed to be a lighthouse. I think there might be some like, yeah, okay, there we go. Oh, it's a lighthouse. There's some draw distance things going on. And you can see some real-time reflections on the water there. Isn't that nice? Okay, that was that. What else do we have? What is this? All right, this is this thing. What's physics system hacking? Right, so I'm basically trying to get a system that already works in this game. Let's see if we like spawn an explosive barrel here. You can see when that barrel falls down. Actually, it didn't do it now. I probably need to do it over like gravel. When that thing falls down, there's like there's a particle system there, which you can see. Boom. There's some particle dust appearing. And actually, that particle dust doesn't appear if I place it here. It's figuring that out based on the fact that this is actually gravel, and this is like just the standard default material, which doesn't have any sort of effects. And I'm just exposing that to Zig basically. Fun. I guess there's some redeeming qualities to this game as well. Not all bad. Yeah, so I need to expose the same sort of system to Zig interaction point so that I can play the correct sort of audio when you drive your car into like a wall. For example, I want to have like a crash sound from that, and later on also spawn particles. What else do we have? Asset preview level. Combat demo version 6. Oh, Jesus. Yeah, the grass is completely broken here. here you can actually see an earlier version of the elevator from Traction Point. This was supposed to be an elevator as well. Bring it up here. Just messing around with things. Yeah. You can see that the mission didn't end, even though we went out of that level there. Oh, is this the thing with all of the exploding barrels? It's not, but we can put them there. So here's a physics test. If I can just fill this up with explosive barrels. The idea here was to stress test the physics system, and you can do that by filling this whole thing with explosive barrels. It's a little tedious to do it like this. Much easier if... Do I have a... No, I don't have a layer for that, unfortunately. We fill this with explosive barrels. Explosive barrels, when they explode, they give damage to other explosive barrels and vehicles. But basically what happens is that these things go flying, and it's fun. Let's do a few more. And maybe I can get some fireworks for you guys. I think I had maybe like a couple hundred of them when I played around with this last time, but we'll have a few. Alright, so the firepower is in place. Let's see, can this thing work? It looks like it's working. So I'm gonna drive up here and shoot some of these guys, and then drive off when they are about to explode. So just some of that. None of them are burning yet. Yep, okay, there we go. Let's see. Oh, that was very... that was very... anticlimactic. We need to shoot some more. Okay, now let's go. Let's go. Like a chain reaction going. There we go. Fireworks. Hey. Fun. Yeah, it's pretty fun actually. I haven't played this level probably for like 3 years or something. It's fun to see that the tech is still sort of there. It hasn't deteriorated beyond being able to run this thing. That's kind of why I've kept this game alive, because it's a pretty good test bed for just making sure that stuff works. I think some of these were like, if I shot them, they went after me, right? Is it that one? No. But I do remember actually testing out the AI in this level back in the day. So if you shot one of these guys, they would hunt you down and kick your ass. All right, maybe that's enough reminiscing for today. So, what was I doing? I don't remember anymore. So let's try to get this working today. Still, there might be some stuff that I have to do tomorrow. It's getting kind of late here, but I'm gonna keep going for a bit longer. Let's make sure. Was this now in a state where it would build? It is. Okay. And I think basically like everything here is pretty much done, right? We have the collision point, the collision data. Oh, this one actually needs a little more stuff. So there's the collision points, maximum 8 of them. Let us do this. Let's do a pub const max collision points. Max collision point count probably 8, and then make this collision points, and that would be a stud bounded array of collision points. Max collision point count. Like so. Yeah, there's one stupid thing about this bounded array. It's the fact that these guys are not initialized here. So you kind of need to... oh no, that's... sorry, that's not what I meant. Those are the comp time ones. Things I'm actually looking for are... Where are they? They're over here. Well, actually, they are now. Okay. I remember them not being in an earlier version, but they are now. So that's actually probably okay then. I can just do this. That should still build. Alright, it does. Good. Hey Tutu. You're a little late, you just missed the fireworks. You can go back and watch them about 5 minutes ago. If you can see them on the rewind. Or you can watch them later if you want to. Okay, I think we have everything here that we need right now. The not necessarily tricky part, but sort of annoying part is going to be to actually convert between the interrupt type and the actual type, if you want, if you will, collision data. That is. But this works, so we can construct one of these guys. That's good. Of course, this thing doesn't have any members yet. Shouldn't be very tricky to do though. Yeah. So we just add them like this. Normal, impulse. Force can just be F32. And these materials are going to be int pointers. Same for the other one. Like that. Actually, yeah, shapes are the same. They're also int pointers. Shape. Fun memories with older videos where stuff was flying around while exploding. Yeah. Okay. You have me convinced. Because the stuff that you saw 5 minutes ago, that wasn't the whole thing. Let's see if this works now. Test levels, I think. No, it's regen. What is it? Which one of those is it? Regen demo. Maybe it's actually regen demo. Regen test, yeah. Yep. This is it. Okay, here we go. We have more barrels here. I don't know why these weren't. Okay, so we have explosive barrels. Yeah, that isn't auto loaded. That's why. Here we have some. Yeah, this is like the old AI system from this game. It had like a patrolling system where you could set up these paths. And they would patrol. So that's kind of nice, I guess. Anyway, we'll want more of these. How many do we have? 99. Let's do like what is that? 60 more. Duplicate them. Move them up. And let them drop down. Bloop. Alright, that's good. And now... no. Actually, it would probably work with the web GPU as well, but oh well. Alright, I'm gonna... Ah, yeah, still don't have those. Let's auto-load that thing. Let's try with web GPU this time. Yeah, okay. Clearly doesn't work with web GPU. Alright, now the game does work. I don't know if there's some material or something in this. Okay, bye-bye. That's not good. Ignore. There's some bad stuff. Bad stuff is gonna happen now. I'm pretty sure of it. Okay, get one of these guys. It's very, very loud. Alright, we'll just blast into the thing. Alright, let's move the camera back. Oh, that wasn't enough. Alright, I'm on. Yeah, now we're talking, because now we're seeing the status text for all of those things. Now we're cooking with fire. Oh yeah, this is the good stuff. Not sure if it actually probably didn't ignite all of these guys. But quite few of them still. Yeah, I remember playing with this so much back in the day. There's still. We can do another boom. We can do another boom. The texts are a little annoying, and you can see that the transparency sorting going a little crazy. Hey. Yeah, still haven't made everything explode. Several of these are still like not burning. So the hit point system here is sort of like it was never really finished in a sense. You can shoot these guys. At some point they're gonna start burning and counting down, and when they reach 0, they explode, giving off like this. They reach 0, and then they explode with a very unsatisfying explosion, and then they just keep burning after that. You can still actually shoot at them. Nothing happens. But it's that one very unsatisfying small little explosion that causes the chain reaction. All right. Fun stuff. Yeah, I really should put trailers into traction point as well. All right, this thing can't haul. Obviously, it can't haul. Yeah, trailer should just be it should be possible now. Just like a little bit of code should be able to make trailers. And everything is burning. The whole countryside is burning. Oh no. Burning and flickering. Yeah, the flickering comes from the fact that we are reaching some limit with this is the old particle system. This is not Merlin. Merlin is the new node-based particle system that we use in or I use, I should say, in traction point. This is the old one, which still works, but it's a bit more limited, and we reach some fixed list maximum length or something, where it just starts dropping things out, and then when you move out it sort of sorts them differently, and then that's why it's flickering wildly. But yeah, it's fun. Fun. Okay. Alright, back to work for a little bit more. So, interrupt collision point. We basically need to have these, we need to mirror the sort of actual ones, right? So this is just a normal vector tree struct. Interrupt vector tree is an extern struct, and it's just enough to hold the data for vector tree, so we can just pass it back and forth between C and Zig. All of the basis PTR types, like material PTRs and shape PTRs, they just become int pointers. Interrupt collision data still needs these collision points. So this would be a what is it? Basis physics collision data max collision point count. This is going to be one of those absolute monsters of a line. Right, so it's basically this thing here. I can never remember exactly how to write this. I need to look it up. So it will be, that's the actual declaration, and then we assign it an interrupt collision point default value times this. Just absolutely massive. What a line. Let's maybe we can shorten that. Yeah, let's take those away. Another way to do it would be to just set this as undefined. Like that, right? And then we have collision point count. Count u32 equals 0. Like that. And now we have even this thing figured out. And then engine API actually needs to do the work. So it receives a pointer to one of these guys, needs to basically copy that stuff over. So let's see. Shape 0, this should be basis physics shape pointer. Yeah, I don't have like an init from CPP pointer here, but this is the only field. So we can quite simply do this. And we can do .cpp pointer is interrupt collision data shape 0. Like so. Shape 1. And collision data collision points dot len, and this probably needs to be an int cast, I assume, and it is interrupt collision data dot collision point count, like so, and then for 0 to that very count we have an I, and we do collision data dot collision points I. No, we do slice I. And CLS can't show this to me. Okay, I happen to know that it should be that. Let's see, interrupt collision data, collision points. It should be able to show me this. Yes. Right, so that's the interrupt type. So we can do like vec3, but it's basis math vec3 from interrupt, like that. See if that builds. it does. Yeah, this is a little annoying to work with this, so let's call it data is the address of. I want to make it very clear what I'm talking about here. So there's a pointer to a collision point. Let's call it point instead. This is physics collision. It's actually probably here. It's a physics scene collision point. Is that thing. That's the thing we want to assign to. And then we can do pointed position. Normal. And impulse. And force. Force is just a matter of copying it over. And material 0 is, maybe I should do this as well. Let's see. Source is one of those guys. Now we can make this rows much shorter and nicer to look at. The source, actually it's probably basis physics material pointer, and it also probably only has that one int pointer. Yes, so it's that, and we have CPP pointer is source dot material 0, and that's all the interop work we need to do here in Zig, luckily. Still quite a lot of stuff to copy over though for every collision, so I might have to look at that at some point. Optimize it a little bit. Anyway, let's hope this now builds. I think we're basically done actually with all of the Zig stuff on this sort of system level. If we wanna use it to actually render something, test it out by rendering like a visual where all of the collisions happen, then we need to do that, of course. But on the sort of system level, I think this is all that we need to do. Those can be left out. Yep. And one thing that I was thinking we probably need is a way to let the C++ side know that, hey, we are interested in collision callbacks for a particular scene. So this thing somehow needs to notify. But maybe we'll do that as part of actually calling the register function. That actually probably makes sense. So when we call register collision callback, we give it a scene here. This thing not only appends the callback here to this list of things, but it also sends some sort of signal to this scene that, hey, we want to start receiving callbacks now. And if we want to do that, we will want to go into the bind-a-lot file. Scene, it's just scene, right? It's physics scene. It's physics scene. So we'll do void set collision callbacks enabled. scene CPP pointer. That's sort of like this pointer in this case. And whether or not we want it enabled or not. If you're wondering what this bind a lot business is, this is my custom system for actually generating bindings to a C++ class. So now we'll run this thing, have 0 errors and 0 warnings, but it has actually gone in and generated some bindings for that new method of ours. So, and that's, for example, how all of these, if we go back to the scene, we have an adjoint method here on the scene. This thing was actually generated by bind-a-lot. You can see actually our new callback here already sitting there and waiting for us to use it. So with the Zig physics bindings, if we try to build this now, it will actually fail. You see right here, it's waiting for that very same thing to be added here. So let's copy this guy, this row or line, and place it under this. So we have it in the same place as in the bind-a-lot file. Like that. Now we just go here and enable that. Now it should build again. So now if we call that on the Zig side, this guy will get called with the CPP pointer, which we can turn into an actual scene pointer with a reinterpret cast like that. And basically we need to somehow do something with this information. So scene has an add collision listener, which we need to actually add to it somehow to act as a sort of an adapter between the C++ collision mechanism and the Zig code. Yeah, there's actually quite a lot of stuff to do here for the whole chain of collision data to arrive on the Zig side. It's a little annoying to be honest. But it can't be helped. All right. The other thing that we need to do is we need to actually call this on collision callback somehow when the collision happens, right? And this interrupt collision data, this comes from the physics system itself. And the C++ side can put one of those things together once we've defined it there on the C++ side. Send it over, we do sort of the reverse thing here, and then we call this, which calls the callback that we set up. This int pointer here, this needs to come from the actual scene. So it's basically the same thing that we just sent over here to this thing. So basically, once the game is up and running and we call this, we set collision callbacks enabled for a scene. Whenever there is a collision in that scene, it needs to cast itself into an int pointer and fill this in with the data, and call the Zig side. So we need to call this method or this function somehow. So let's search for that trigger one, and we should find a bunch of things here that are of interest. Yeah, C calls Zig. Absolutely. And here is where we want to actually put those interrupt things that we created here. So let's do that. Let's take these two guys. I'm just gonna comment these out like so. We can do the same thing here. And this is now C. This isn't C++. This is C. So we use like the proper type def struct way of defining a struct here. And then we call it interrupt collision point without the underscore there. So we have position, normal, impulse, force, that's a float. We have uint pointer, material 0, and uint pointer material 1. Yep, that's that. And then we have the data side. So type def struct underscore interrupt collision data, and then just interrupt collision data without any underscores. Max collision point count. I mean, I know that is 8, so we can probably just set it as 8 here. Would be nice if we would actually use the define for that, but 8 doesn't necessarily matter. So we have shape 0, that would be a uint pointer. I've been writing too much Zig now. Do everything in Zig syntax and then I get confused when my C++ compiler doesn't like it. Shape 1. Collision points, so that would be collision points 8 and uint 32 collision point count. Right. That's basically it. And now we can go here to this place and we can set up the type def. What was the name? It was on collision callback. That's the name of the function. It takes a uint pointer and it takes a const interrupt collision data pointer. Those are the things it takes. So that's just a type def for a function pointer, just that it's a little easier to use. And then we create one of those guys. We create it here. Physics on collision callback function. Oh, did I forget the function? Yeah, I forgot the function. So the type is called physics underscore on collision callback function, and the field is called the same without the function, just on collision callback. That's how all of these things are set up. You can see like export level function. And with this, we can call this nifty little macro that I have here. Like so. So what the macro does is it basically just gets when we load the Zig library, which is a DLL, which gets loaded at startup time, we get the function address out of it and assign it to a field with the same name. So basically we're getting the address of this guy and storing it in this guy. So now we can just, whenever we call this thing on the C++ side, this guy gets called. That's how it works. Okay. Almost there. So now if we build, let's see, if we comment this thing out, like so, we build the engine, which hopefully shouldn't take that long. We still only modified the interface, the C interface a little bit. Like so. So now if we run this, it actually probably doesn't work. Yeah, you can see. Could not get address of Zig function physics on collision callback. So at startup time, it's actually going in and trying to find all of these things. You can see that it fails on the exact line that we just added. Hook up exported Zig function. So these are all the Zig functions that we hook up when we run. When we start the game, you can see most of them are actually just binding methods. So these are binding a single class typically to the Zig side. So we added that set collision callback enabled method to the Zig side physics scene, and that thing would be, that's physics shape. Physics scene is probably here somewhere. That's probably actually just called scene. Bind scene. Bind scene. Bind scene node. Maybe not then. Bind physics scene. There it is. Yeah, so that method gets hooked up here during this call. Okay, good. So to make this work again, what we need to do is bring that function back. And now the game runs. Okay. I'm gonna go get some water. 1 second. All right. Actually, spoke about the old particle systems earlier. These flashes here are actually still using that thing. I think that's probably the only thing still using the old particle system in this game. I just happen to have a nice little particle thing sitting around. But these dust things coming off the car, these are not using that. They're using the new Merlin system instead. Yes. Okay. Right. So now we have almost everything done here for the actual communication. The only thing we need to do still is call that new method that we bound. And I'm going to do it here as the last thing in this register collision callback thingy. So this would be basis bindings fb scene node, no, physics scene set, right, okay. We need to restart CLS here for this thing to actually pick up on our changes. Alright, there we go. Physics scene. Now we should have set collision callbacks enabled. So the first one would be scene dot CPP pointer. The next one would be actually 1. So enable them, and in the unregistering we disable them. There we go. So that's everything we need to do. So these things were sort of registered as methods, so member functions of the physics scene class. But to Zig they still look just like function pointers. They're not really like members of anything. So if you pass the scene here, we're just calling this function and passing in the self pointer or this pointer like this. That's all fine. Still looks good. Yeah, I assume you mean the particle flashes. Yeah, I thought they looked pretty nice. Thought they looked pretty nice, especially from afar. They look kind of nice. Okay. Yeah, I think we're done now on the Zig side, except for actually using this for something. Pretty much done now. So the annoying thing is that we are going to have to set up a listener. A listener here, and actually call this callback of ours. That shouldn't be super tricky. So the way we do this in C++, it's kind of simple. We get a scene, so this returns a physics API scene reference. We just add collision listener, and then we give it a pointer to something that derives from scene collision listener, which this thing happens to be. So that's kind of easy. It's not as easy here, but it shouldn't be super tricky. So I think we actually had some trigger business, some related stuff here that we can look at. Right, it just has the events. That's fine. That's fine. It's not really the same thing, but I'm sure I can figure out how to write this. So let's create a class here. Can I actually create a class? This is a yeah, that should be fine. There's no external C or anything here. Nope. Okay. So let's call this Zig collision listener, something like that, and it derives from basis physics API call scene collision listener, just like this. And where's API? API is here. Okay. API is the thing that actually has the function pointer to the Zig side that we want to call. So we need to somehow poke that into this guy. That should be fine. Let's quite simply add it here as a member, and we can have it as a pointer API like that. And maybe we'll be good citizens and actually initialize that to like null pointer like that. And we'll add the actual thing here. Actual thing is what is going to get called through the magic of polymorphism and virtual functions in Zig, so or in C++. So this thing gets called. We want to create like an interop collision data, interop data here, like this, and then to do fill in the interop data, and then we want to call MAPI physics on collision callback, right? Oh damn, we don't actually have the scene pointer here. Yeah, this is what we in the business call an annoying freaking thing. So get the scene pointer here. And I was hoping to have just one of these listeners and it would work for all the scenes. But that's not gonna work, is it? That's not gonna work, is it? Like, we know that this guy is only gonna get called once at a time, even though it might get called from multiple threads. And we know that because copy that part. No, it's not there. It's here. We know that because we're sitting behind a mutex here. Can you request the scene pointer from the API? No, the API is there's only one API. Yeah. There's only one API. It just comes in here when we're binding the physics. So I can't do that. But what I can do is this. I can store this here. mscene cpp pointer. We can set that to false as well, or to 0 as well, like this, right? And then now we can call cpp pointer and address of interop data. Like, the annoying thing here, if we're being completely honest, is that the receiver doesn't even use this for anything except it identifies the callback with it. So this could be like a freaking, I don't know, 8-bit unsigned integer or something like an index. Anyway, now that class kind of works. And what we can do here now is something like this. We can do listeners, have like 8 of them. Oh, that wasn't supposed to be a big G. And 32T. Count is 0. Right, we can do this. And we can basis assert here that you know, this is smaller than 8. And then we can do listener is this guy plus plus. Right, now we have our listener, and listener dot CNCPP pointer is CNCPP pointer. Right. We still need to fill in this API here, and that we can do down here in this bind function. We can see that we do some slightly similar things here as well. The code is a little messy when we have to do things like this. It's not that it's going to be like terribly inefficient or anything. It's just like it's a little messy. Don't necessarily like it all that much. But we can do it like this. I think technically that never gets run, and we can make that a struct, which means that we can remove the public like that, make it a bit simpler. Viruses and threats. Yeah. Let's define that as 8 and 8. And then down here we can do this function gets called at the very beginning, like it gets called once at the very beginning of the program. So nothing has been actually called, just hooking things up at this point. So we can do 0, I needs to be smaller than that, G collision listeners I dot API is API. What is that? That's a reference. Okay, like that. There we go. Now we have everything we need. I'll just do that. It's annoying to have it unindented like that. Okay. So that would be now that thing, and then this is global memory. But again, that's fine because we're sitting behind a mutex here. So now we can do scene, add collision listener, address of listener. Right, assign one of the listeners to this scene, like this 8 is going to be more than enough. I mean, this is just a few bytes, so it doesn't really matter at all. But this 8 here is going to be more than enough for almost any case. And if it's not, then this assert will fire, and you can go like, oh, okay, I need to bump that. So that's fine. Of course, this is only if we are actually enabling, right? If enabled equals 1, and this int bool thing is really just an integer. It's a type def for an integer. It's a workaround for an old Zig bug that I'm pretty sure we've gotten rid of by now, but still, that's how I've handled it in the past. So now we need to find the listener. If g zig, no, not mzig, but g zig zig collision listeners cpp pointer is cpp pointer. This thing we can do all the time, or in any case, I should say. Scene remove collision listener. And that's like the address of that. Right. Maybe we'll do this here as well. Let's not do that though. Let's do I. It's that thing. And we'll want to. Yeah, we'll want to actually reset this probably. Not the API, but the scene CPP pointer. So something like that. Actually, it's not even initialized to begin with, so that's fine. That's fine. That's fine. So one thing that is going to break here is if we are creating and destroying a scene over and over again, which we might be doing if we're reloading the game on the server. I don't remember how that works, but that might be the case. Like, first of all, we're not actually hooking any collision listeners probably on the server, at least not for this audio work that I'm doing this for. But we might be at some point, I guess. And I don't remember if the physics scene is actually destroyed and recreated when the server is recreated. But if we're assuming that we will want to hook up collisions, and that the scene is created and destroyed, and that the server is actually recreated when we reload a game, then this thing will crash after like 6 or so uses. Or maybe 4 uses if we have client and server and we have 8. So that's also not good. So how do we do that then? Well, we hack it further. In use. And we'll just remove that completely because that's not relevant anymore. Fortunately, I wrote in the title of today's video stream that we're going to be hacking. This is hacking at the highest level. So that can go away. Bye bye. We need a return there as well. Enabled 1. If we are enabling it, then we are basically doing this. If listener is not in use, which we actually need to initialize to be false somewhere, then we mark it as being in use. Set the scene CVP pointer, and we add the collision listener. Right, if we are unhooking it, then we do this, just like before. We mark it as not being in use anymore. And then we return. And we don't need this for loop now. That for loop is not supposed to be there. And actually we can bring this whole thing there. Right. So when we're enabling, we want to just find the first one that's not in use. When we are disabling, we want to find the one that we previously used. Yep. That's how it needs to be. And then if we get here, we can do like, what? We could not find, like, free collision listener could not be found. Did you forget to unregister or forget to disable collision callbacks or use too many at a time? Question mark. Yeah, that should be all right. So now the only thing we need to do now is actually go in here and just set all of this to be not in use. In use false. And maybe we can be a bit nicer about it and set that to 0. We could set it back to 0 here. Makes it more clear when we inevitably have to actually debug this at some point. Right. Does that make sense? Have I made any mistakes? I think that should be everything we need. The only thing we need to do now is fill in this interrupt data, which again is just as annoying as always. Let's see, where does this thing actually come from? Who is calling what? Right, so now we're inside PhysX. And PhysX has a similar sort of thing called onContact. And this is actually a member function of the scene. You can see we're inside scene PhysX, which derives from scene, which we've been messing around with now for almost all of tonight. Now this guy figures out some of these pointers for us, converts the PhysX stuff into a collision point, and then puts the point in the collision points list, and this collision data is what we eventually get out. Yeah. Also there's a wee bit of converting going on here. Not super happy about that, but we'll see. Maybe it's fine. Am I actually, by the way, do I have a profile block here? Yes, I do. Okay, good. Sure, this is something that's going to show up in the profiler if we have enough of these listeners. Okay, And now then, one more time back to where we just were, which I somehow lost. Oh no, it's right there. Put that on the side so we have some reference to work off. Collision data has max collision point count, right? That's actually declared as a thing. Although it probably actually has a member for it, right? Yeah, okay, that's good. Right, so I0 should be smaller than collision data dot collision point count, like so, and we have this guy I point. Oh, not yeah. It just points and then I. Do we actually have some? We have two interrupt. Yeah, there we go. Helper functions here. Like that. Right, so position, normal, impulse, if I can't type it, apparently. Force, that's just collision data, collision points, I, force. Those are reinterpret casts, those materials. So material 0 would be collision data, collision points, I. So that's a pointer. Yes, it's a pointer. So we just do a reinterpret cast into a uint pointer, and that's how we get our int pointers on the Zig side. And 1 and 1. That's all. Those are all the points. And now we just have the. Oh, actually, we need the point count as well. Point count. Oh, it's actually that one. That way. And we have interrupt data, so that would be shape 0 and shape 1. Shape 1. Shape 0. And I think that's it. I think that's everything we need to do. All right, I think we're done. I'm sure this is going to crash when we run it the first time around, but I think we're done. So what we should be able to do now is set up a small system in Zig, which what should we do? Maybe draws all of the collisions registered within the last X, or perhaps like the last X or last N collisions along with their force or something like that, right? Let's try that. This now built. That's good. Let's hope it actually runs. We should be able to run this now, just normally, and everything should work. Let's try that first. And of course, for those who weren't around in the beginning, the reason I'm doing this is so that I can play like collision sound effects and particle systems and that sort of stuff from Zig. All right. stuff seems to be working. Spawn exploding barrels when collisions occur, maybe. Unfortunately, I don't have the exploding barrel behavior here in this game. There are no exploding barrels in Traction Point yet. I'm sure there can be. But I don't have them yet. I do have, I think I have, let's see. Spear sweep, yeah, radial impulse. Yeah, that right there. That's your exploding barrel force right there. Am I actually using that for anything? I don't think so. Yeah, no, it's just the binding classes. Force, am I using that? No, apparently not. Yeah, so we're set up to do exploding barrels, but we don't have them. Right. At least I think that's how it works. Explosive object component. This is from slide. Right, so we're doing fire damage when we reach 0, and we haven't exploded already. We explode. This is a bit crap. That's what I've thought about this. Yeah, radial impulse. Exactly. That's the thing. Yes, indeed. And then we're doing giving some damage to the other ones. Yes. Anyway, cool. What do we do now? Let's do something. Let's do something fun. Something a little fun. Something that can be easy to add and then just take away. Right. So let's do something on the client. Only client collisions, because then we can just easily draw them. So let's add a new component. Let's call this collision callback test component Zig. And we'll do a Z comp, we'll call it the same thing. I'm gonna add means dot there. So what do we need to do? We don't need to have any messages. We don't need to tick. We do need to update if we're going to want to draw those well, visualizations. I was thinking like we would maybe draw some spheres, some debug draw spheres at the position where the color specifies how much force there was, right? So let's do like a const collision struct position. This would be a math vec3 and the force is just an F32, and we'll initialize those both of those. Vec3 0. You should make it reasonably obvious if the system is working or not. That's what I'm thinking. And of course we can go crazy and query for the materials and all of that, but let's start with this. Right. So I'm gonna do. Actually, make another section there for the declarations, and then I'm gonna make a buffer. Let's make it a basis ring buffer of collisions, and we'll keep 128 of them. In memory. Right, that just needs to be initialized. I like to make an actual declaration for those so that I can then just do this init like so. And right, now we can actually make the callback here. So we'll do fn on collision self collision data basis physics collision data, and it's a void method, right? And then if self on context on client and not in editor. Not that I really need to check that, because we can just create this in the game, not in the editor, but oh well. So self, or actually it's not self, it's basis.physics scene. Right, and our new functionality here. So this would be, we need to get the scene. Maybe we can actually just get the scene quite simply. It's there. And yeah, I could shorten this, but I don't feel like doing it. Null. So we do self context get primary physics scene. Actually, I'm just going to assert here that we are on the client. S assert source self context on client, and then I can just get rid of that stuff completely. So now we can do scene is self.scene, and here we have as the callback we do basis physics scene collision callback, and we can either use just a freestanding function or a method as the callback, and we choose the method one. Receiver is of type self. No, receiver is self with small s. Receiver type is self with big S, and then on collision. I just want on collision, but Visual Studio Code wants to give all of the parameters there as well. Right, that's a bit of a mouthful, but it works. And then we do basis physics scene unregistered callback, and we just do self scene like that. Okay, and we can even just move everything there. We don't need that on object created crap there. Let's comment it out instead. Okay, so now then I'm go to on collision and we do self buffer pushback collision. Why are you being nasty? Mission data. All right. Yeah. Okay. Of course. It has a bunch of points, doesn't it? So for collision data dot collision points dot slice, and we get a point out of it, something like that, and then we do this. So we're not drawing all the collisions; we're drawing all the collision points. But okay, let's just call it collision for now. Collision position is point dot position. It has a position. Come on. Why don't you want to show it to me? And force is point dot force. Right, that should build, I think. Yes, it does. Cool. So last thing then is to iterate over this guy. So self.buffer.get count. Actually, it's 0 dot dot and then that. We get the I out of it, and we can quite simply call self buffer get back offset I. Doesn't matter. We can iterate over forwards or backwards. And now we need to somehow figure out a color for this. Can we lerp colors? This is color linear blah blah. Okay. Okay, can't lerp colors. Can we lerp colors on the C++ side then? Lerp. Can't lerp colors. Okay. How unfortunate. Anyway, let's just lerp from like white to red, so it's basically just one single component that we're messing with. So let's do const color red equals basis math remap float from, and we do call force. So if it's very, very small, the force would be 0, and if it's very large, the force would be, I have no idea actually. I literally have no idea. I don't even remember the unit for that. Oh, actually, it's not the color red, it's the color green blue. It's the one that we want. So if this is 0, we want it to be 1. And if it's you know, a large force, we want it to be 0, so that the thing becomes red. Right? That makes sense. We actually want it to be 255. And then the color, const color is basis color from, or is it init? It's init. Init, come on. Init RGB, so that would be 255. And we probably need to cast that to like a U8. So green, blue, U8, int from float. Yeah, green, blue, green, blue. That's the color. And then we do, and we could of course just do all of this when the collision actually happens, and then just store it there. Maybe that would be nicer. Anyway, let's try this out. Basis, debug, draw sphere, and the center is at the call position. The radius is, I don't know, 0.25. Oh, it doesn't work that way in Zig. And that's just color. Alright, is that gonna work? I don't know. Maybe it is, maybe it's not. We need to throw this component somewhere. First of all, we need to actually register it. Yeah, that one. Not sure I'm gonna keep this component around, but let's keep it for now. This is actually the first time the thing even gets built, because it, yeah, you can see that I had some things here that didn't quite pan out. Error union is ignored. Okay, right. So it has to be try. What is this? Collision callback state. Oh, right. Yeah. So this is now, again, this is the first time this code gets actually compiled. There's that thing. Ordered remove. Yeah, I don't need that. I can just do that. Yeah, I need to put it on something. Absolutely. I need to put it on something. That's also try, isn't it? Yes. Oh, I changed it actually. I changed the type of this to be a const pointer. Const pointer. Yeah, okay. So now we're actually building this code that we wrote. Yeah, that's something that's a little annoying with Zig. It's sort of a fundamental thing with how Zig does comp time, that it doesn't compile code that's not actually referred to, but it can lead to some confusion sometimes. Okay, so we can just take this registration name here. I'm gonna throw it on something. We can, for example, throw it on the game master. If I can remember where it actually is. Is it gameplay? It is probably gameplay. So game master base. This is the game master is a component or is an object which is created as the very first object when the game starts. We have a base for it. We have a default game master, which actually derives the base type is this one, and it puts a means game master component on it. Then we have a campaign game master, which is the thing that is actually running when the campaign is active. But we can just throw it here. Collision tracker, whatever. It's gonna complain that it doesn't know what it is, but we're like, yeah, it's fine, just put it there. Only the client, thank you very much. And run the game. Okay. So far it seems like we're not seeing anything. That might be completely expected, or it might not be. Let's get rid of the music for now. Do something like that. See if we actually get there. Yep. We're creating this. We can go all the way here and have a look at what is actually being created. And we can see that it is indeed the game master. Yep. Okay. A good. And we are doing it on the client. All right. Then my question is, why don't we see anything? So we're registering the collision callback here. Put a breakpoint there. We should hit it when we actually shut the game down. Also doing the update. Are we hitting this? Yes, we are. Okay. Good, but we're probably not hitting this one, right? That thing is not being hit. Nope. Dynamic crate. Oh, there we go. So okay. So the wheels don't actually count as a collision, right? Or something. Yeah, the wheels are kind of magical in the physics vehicle SDK. It's a magical thing, right? So we're getting here. What's going on? What do we have in our buffer? Okay, we have just zeros. Okay, okay, that's fine. It's probably like if we put a power cell there. So what is in the collision data? Collision data has 4 points, but they're all zeros. Okay, that's not good. The nice thing is that we can just step directly into physics here and see what's what. Right, so we have some positions here. Why are these guys not being sent over to the Zig side? Interrupt collision data. The interrupt collision data still has those things. Okay, do they have them here? They do not. Now, have I just quite simply forgotten to actually do that? So the collision data 0, but the interrupt actually has valid stuff in it. So I'm fudging this somehow. Right. Okay. I see what the problem is. This needs to be a pointer for it to work. otherwise we're just making a copy and not attaching it, or not writing it anywhere. Alright, what's going on? What's going on? What's going on? Hey, look at that. Hey, look at that. Oh, this thing's a little bouncy. Why are you being bouncy? That's stupid. Stupid bouncy thing. Boom. Now they fell asleep. Right, so yeah, the wheels don't actually act as collisions. It's kind of expected, if I'm being completely honest. You can go like boop, and if the chassis hits something, boop, we get a hit. It's not like necessarily. Yeah, I need to figure out the scale of that force thing, like how. Actually, let's print it. Let's print it. Yeah. So now we get the unregistering thing. So that's good. The whole sort of life cycle of this system works. That's nice. Let's print the force. Let's use the force to print the force. How do we do this? How do we do this? Blah 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 blah. I need to make like a buffer. Text buffer. Actually, we can put the text buffer outside of this thing. Var text buffer. Let's make the text buffer like 32 UH. There needs to be a colon there. No? Is it let's go there. I don't know how to do things anymore. How do I make a friggin'? Oh, it was correct. It's just mad at me because it's a var. Yeah. Hold your horses. Text is stud buff. No, fmt buff print. Address of buffer. Address of text buffer, and force would be 2 decimals, 3 decimals. I don't know, something like that, and that would be call.force. And then draw string text. World position is, yeah, that's call dot position, and color can be color. That's fine. Stop reading your mind. Okay, I'll try. I'll try to do it. What did I do? It needs to be tried, probably, right? It's that way around, if I remember correctly. Alright, we have a bunch of forces around. That's good, I guess. Dynamic crate, plumps. Right, so we have some 0 forces, and then we have some quite large forces, quite heavy. 4,000 power cell. Yeah. Okay. Yeah, so the forces are actually they're pretty large. Let's be grown-ups and actually go and look at what the unit of that thing is, right? Scene physics. on contact, isn't it? Or is it? Let's have a look. Peak simulation event callback. It's this thing. On contact. Alright. Contact pair. Shapes, patches, blah blah blah, patch count, flags. That's the force. Contact impulses divided by delta time. Buffer containing applied impulse date. That point is only valid if the information requested for contact report pair. Okay. That's not nice. So it's the impulse divided by delta time. That kind of makes sense. What is the impulse? What's the unit for impulse though? Like we can look at the collision effect manager, this thing here. Actually, the thing that this queries, get effects for material. Actually, no, I lied. It's here. Small force threshold is apparently 300. Whoa. 300, 1,000, 900, 1,500. It's interesting. So some of these forces seem to be like super very large. Let's make that 10,000. Yeah, I assume if we go to scene here and then we look at the actually it's probably not that, it's like dynamic object. If we apply an impulse, add impulse here, well, this impulse is like a directional impulse, but add force at position, force or impulse to add. It's interesting that they don't actually say what it is, but I guess that that depends on the scale that you're using. Hello, Lukas. Long time no see. Let's see. PhysX guide. I'm not at 5 yet, so let's go with 4.1. Hold an object rendering and blah 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 blah. Unit. Using different units. Yeah, I don't actually know. It's probably like unit of force. That's like a Newton, isn't it? Yes, it's a Newton. And since we're dividing it by with the delta time, maybe it's quite simply newtons. It is possible. Assuming that you are using meters as your unit size. Like 1 world unit is 1 meter in basis. For example. So maybe that's just newtons. I don't know. All right, but now we have some slightly different colored forces here. That's interesting, I guess. For some definition of interesting. 8,290. If you just drive like straight into a wall somewhere, we should be able to conjure up some pretty big forces, I assume. Let's see. Already hit the ground there. Boom. Right, so these are pretty large. What is that? 197,286. Is that over a million? No, it's 109. Yeah, it's over a million. It's 2 million newtons. 1,958,962. It's like 2 million newtons. All right. All right. All right. Try to find my master valve here. Master valve 0.2 maybe. Prevent this from just screaming at me. Yeah. Yeah, so they're pretty huge. Those things. We can also see that this looks like it's kind of slowing it down. It might be the debug drawing. Debug drawing is not particularly fast, especially if you're doing lots of it. But it might actually also be the collision report. Actually, it's not. It's not. Of course, I'm stupid. It's not, because those collisions are not happening now. Yeah, it's not. So it's just the debug drawing being slow, which is, I guess, fine, or at least better than the collision reporting being slow. Boom. Yeah. Okay. That was weird. Like 0, really. I don't believe you. And now we're now we're just spamming the system. You can see that we're spamming the system because the ring buffer is running out of places. Yeah. Yeah, that's not good. Okay. Well, I probably have to do quite a bit of filtering on this stuff to actually be able to use it for some sensible things. My thinking is that I will have some sort of centralized manager which keeps track of like how many collision sounds we've been playing. Oh, what? What? We didn't get a single collision from that. Is it because I drove with the wheel into it? No, that's strange. That's weird. I feel like I should have done something there. Boom. Yeah, I'm getting into the million range here quite easily, actually, with this. Boom. So, yeah, not sure what's going on there. And also, if the raycast from the wheel is hitting something, then you don't get a collision like this, for example. Which is also why we don't get those collisions from just driving on the ground, or probably driving on top of things as well. So if I drive onto this plate here, you don't actually get any collisions from that. I almost moved the cliff. Yeah, I feel like I should have moved the cliff. What happens when 2 million newtons faces an immovable object? That movable object doesn't give a shit. Yeah, okay. it's of course entirely possible that I have some bug here related to this force thing, but it kind of looks like it's working. We're getting collision responses in Zig now, so yay. How cool is that? Should we actually end today's stream by doing a little bit of profiling? I bet you guys have never seen this tool. This is the monitor, which I don't think I've used for a little while. It is my frame profiler and adjustment tool. Should be able to find the collision thingy here somewhere. It's actually not in update. It is probably in ticking. Calculator run ticks. Game session, I think. Now we're getting into the actual physics stuff. Oh, there we go. It's actually there. So, scene physics on contact. And it's not doing anything now, obviously, because we're not running the game. But if we are running the game, what will happen? In particular, if we are actually hitting things, what will happen? Bonk. So we saw like a very small nudge there immediately, but we are at like 0.1 milliseconds, so that's not a very large thing. It is, however, worth noting that it runs the whole interop and everything with Zig within that time, so it should be nice. Oh, I need to turn the auto scrolling back on. Yeah, the game runs like absolute shit now because of the debug rendering. Because we're debug rendering and format printing and debug rendering 128 of these things now. Let's just mess with this a little bit. Hello. Hello. Yeah. And the Zig code is even running in debug, if that matters. Bonk. Depends on if you add soft body physics for crashes. Yeah. Yeah, like Beam NG style wobbly cars. Beam NG is super awesome. If you guys haven't played that, you should mess around with it. It's super nice. Okay. Yeah, I think this looks like it's behaving kind of like you would expect. Let's quickly just shut the game down quickly and then run it again and see that we should see that debug renders slowdown thing starting to come in. I'm not actually sure where it is, but it's probably in update somewhere. Like here. Alright, what do we have? a rendering update, or it might be in renderer. Alright, so what's the renderer here? Find render. Well, it can be that low, can it? Claims to be very low. Oh, it's up there. Haha. Yeah, that's what you get for not zooming properly. Okay, so yeah, the rendering is, as you can see, it takes almost all the time. You just have this small difference here between the entire frame and the rendering. It's like everything else. I guess that's typically what you expect from a game. And I'm actually running with the, yeah, we're running the server physics on the same thread now, so we can actually see the server update here as well. Yeah, this only shows the main thread. The server is typically running on another thread, but you can see the server here as well. Server update, and then the server ticking both down there towards the low end. Oh yeah. We can actually do this. So let's see. Set rendering enabled, self enabled bool, void that false, or bool equals false, like that. So we only do this if we have it enabled, and then we can maybe yeah, I was thinking of binding this to the command prompt. That's typically the easiest way to do it, but I think that it actually needs to be a global function for that. Let's just do rendering enabled bool equals false or true. Maybe it should be true by default, like so. And we'll just put that there. And then we can do, this is not stuff that's gonna go into the game, by the way. It's just me trying out things. So we can do basis command prompt, register bool value. Oh, and then it needs a getter for this as well, right? So this needs to be called conv c g rendering enabled. Why does it not want to format this? It's because of some error here, right? It's that thing. Like that, and then we need a getter. Bool, which just returns it. Oh, this is one way you can use the command prompt if you want to. So namespace can just be test. Name can be rend, and set callback would be set rendering enabled. Get callback can be get rendering enabled. On server is false, and help text is nothing. basically, if we want to be able to ever destroy this guy and recreate it, we need to unregister that thing. What's it called? Register bool. What's the unregistering? What? Have I not exposed that to Zig? Oh, that's silly. Okay, well, I guess we won't be doing that then. Something to throw on the to-do pile. Alright. Let's try that again. Put some nice frame overview here. There we go. Something like that. They are on now. Why are they on? Did I not build this? Rendering is true by default. Okay, so that's cool. I changed that. Yeah, you can see some huge spikes here when I actually drag this thing around, because we're blocking the message pump. So we go like boom. This thing is like multiple seconds long. Anyway, now if we do test.rend is false, you can see like a significant drop there in that. Still not running super great though, but like I said, we're running all kinds of debug code currently. So that's kind of to be expected, I guess. All right. All right. Okay, cool stuff. Yeah, for the wheels, I can't use this, but I already started working on another system, which I basically have working already. It's not used for anything, but it's showing me that it's working. So I need to basically calculate the speed of each suspension spring. So basically the rate at which the Jones, as it is called, is changing. You can see it here on the car. Let's turn off that rendering, make this a bit faster. And let's turn down the volume a little bit. You can see it here that it actually changes, and those things are just jumping around because they're running at 60 frames per second while the rest is at 70. There we go. A little easier to read. So if we're moving the spring very quickly, if we're compressing the spring very quickly, we get a large positive value. And if we're elongating the spring, we get a large negative value. And so basically, if I get some proper air time like this, and then I land, then I can use like a large positive value to trigger impact sounds and like this. I'm trying to get a large value here, but it's kind of tricky. Here we can see those wheels are in the air, they have 0. That wheel is now hitting the ground. There's like 4.53. It can go up to significantly higher than that, but only for very short periods. So that should take care of the actual wheels, because they don't get any proper collisions per se with this system that we made today. So that should be good. Yeah, there we have like 13.77. So basically that spring has been compressed very quickly. And then it probably goes negative, yeah, minus 1.01. And so on. Oh, that should be good. And I can also use this to drive if I want to have like the actual spring make some sound. Not that I necessarily do, but if I do, I can use this as well to drive some low pass filter or whatever. But yeah, probably need to do heavy filtering of this data as well. Otherwise, we're just going to be spamming the audio system. So I'm thinking I will have a central manager for these things, and cars and dynamic objects and everything, they just sort of request, they tell the system like, hey, I have a collision for you, or I have a rapid spring compression for you over here at this rate, and then the manager can decide if it wants to actually play sound or not, because if it played like 2 sounds already within the past 2 frames, it probably can just skip it. Yeah, the squeaky pad. Yes, it's this. It's this trigger here. It's the squeaky throttle trigger. Yeah, it's my right trigger on my old Xbox 360 pad. It's squeaking. All right. Cool. Okay. This was fun. I think I will have to look into those forces. They seem a little erratic. On the other hand, we're just basically showing what physics gives us. So not really sure what to do about it, but I can at least look over and make sure I don't have any bugs there on my side. But yeah, this was basically what I wanted to do today, so thanks for hanging out. Now I can go back to audio for a bit, at least after some filtering of this stuff. Gonna try to get the audio in a pretty good place before I move on to other things. I think the demo will be much better for that. Thank you for this afternoon stream. You're very welcome. It's not afternoon here. It's almost 9:30 in the evening. But thank you. Happy to entertain, at least for a little bit. See you guys later. Have a good one. All of that. Remember to like, subscribe, do all the things. Hope to see you in the next video.